So if we divide the Europe in some major climate zones, we can see that unsurprisingly, the southern Europe is most affected by climate change. There will be issues with drought. There will be even higher risk of forest fires. There will be a lot of heat extremes and mortality. To the point where summer tourism may suffer, where crop yields may suffer, and where potential for energy production may. If we go to the north, Atlantic region has mainly the issue of heavy precipitation events, and they are lucky in a way that they will have less energy demand for heating in winter. What it doesn't say here is that they may have problem with heat because of the architecture they have, with big windows where at the moment in summer when there are a couple of warm days, it's getting really very hot in those houses, and they will need to do something about that. The continental region is, well, as we know, cold winters, warm summers. Cold winters are going to be somewhat less cold, maybe, but more changing. Also, the summers are going to be changing from very strong precipitation to extreme heat and weeks without any rain. So we will start getting more risk of forest fires. Risk of river floods will even increase, and in summer, the cooling energy demand, unless we do something nice with our cities. Interesting part, boreal area and mountainous regions, they have some similarities, but the big difference is that in mountains, when it starts getting hotter, any species living there will move up, 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 and then they will not be able to move anymore, so they may die out. Skiing tourism, well, we already had problems with it, and it's not going to get any better. Glaciers, which is a problem with water downstreams. In the boreal region in the north, they may even have some positive effects, so less energy demand, nicer summers with tourists coming there, but it's not all fun. They will also have similar problems as on Atlantic. Their architecture is not made for hot summers. There will be also, we have seen that already happening in Finland. They got some forest fires, which is quite unexpected. So it's a mixed bag for that. And now this is the interesting thing to see. Is the global climate changing, Robert?
Yes, so thank you, Dennis. Yeah, so basically to understand how the global climate or why the global climate is changing, if we look at measurements shown here on the left-hand side of carbon dioxide concentration in the atmosphere. Now these measurements since 1960 until present have shown a steady increase starting from around 320 parts per million, going up to the current rate of around current level of around 410 parts per million. So basically at the moment we're increasing at a rate of about 2 parts per million per year, and this is due to all the burning of the fossil fuels releasing the stored up carbon into the atmosphere. Now during this time, over the last 70 or so years, the average global temperature has increased by about 1 degree in this time frame. Okay, so we need to understand this when we want to look at how the future climate will look like. And so to assess how the future climate will look like until the year 2100, one usually employs climate models, and they need to know how the concentration of carbon dioxide in the atmosphere is predicted to change into the future. And what I've shown here are 3 typical scenarios which are used for climate modeling studies. The first curve here in green shows an early response for the humans. So this is taking into account how the humans will develop in terms of quickly changing over their fossil fuel use and swapping the energy production in terms of renewable energy sources, such as wind power or solar power. And under such a circumstance, one would see then the concentration of carbon dioxide decreasing towards the end of the 2100 to around 400 parts per million. And under such a circumstance, climate models typically only have a temperature increase of around 1 to 2 degrees, globally averaged. Now, on the other hand, it is possible that in the future, we will continue burning fossil fuels as we are at the present level, without taking into account any renewable energy sources. And this will then be the concentration of carbon dioxide in the atmosphere will then follow this red curve here. And this is described as a worst case scenario. And climate models have an average global temperature increase of around 3 to 5 degrees. Now, at the moment, the way things are looking at, we're sort of trending towards a curve which is just below the RCP 8.5. And so this, maybe if we're lucky, we can follow this effective measures where it takes a bit of time for us to change over our fossil fuel producing energy sources to more renewable energy sources, which would result in a more moderate temperature increase. And so these scenarios are coded with the value RCP 8.5, so representative concentration pathways. Okay, so in the results that I'll show, I'll mainly show this extreme case, sort of as a bit of a shock to show what would happen in the future for Europe if we didn't do anything. Okay.
So Robert, wait for a moment. There is something I often wondered about, like, yeah, okay, it's gonna rise 1, 2, 3 degrees. Who cares? Like, are we all gonna die because 2 degrees more? Why do we even care? People are living in places which have 2 degrees more or less. So what does it matter?
Exactly, you're right. I mean, it sounds not that much, but when we think about it, we're talking about an increase in the average temperature. So what this means is that although the average temperature will only increase by about 2 degrees, this means that the extremes that one experiences, so we have to remember it's the extreme temperatures, like the maximum temperature on the day, which results in deaths. These extremes can increase by more than 2 degrees. So extreme cases to 5 degrees, 6 degrees. Okay, so it's these individual events where we have a larger temperature increase than the average. That's the events which result in deaths. And so that's why, although a 2 degree increase in the average sounds not that significant, we have to think that this is actually, in terms of the extreme temperatures, results in a greater increase. Okay.
Yeah, and we are still not all going to die, but it could be quite expensive, right?
Exactly, it could be quite expensive. And the way humans generally work, we come up with solutions to mitigate these effects. And with a larger temperature increase, it just means that we need to increase our investments in the adaptation options to mitigate these effects. Yeah, and so the goal of Clarity is to help understand what these climate changes mean at the regional and local scale, and particularly what we can do about them. So we can see that obviously there's going to be a temperature increase in the future. Well, what adaptation options can be put in place to mitigate these effects? And so that's what the role of Clarity is, to help see how we can mitigate these effects.